Hello students. I wanted to make a quick video here explaining what residual plots are, because often this is an area where my students have struggled a little bit and are a little bit confused as to how to create them and what they represent. So let's start with a definition. What is a residual plot? Well, it allows us to determine whether a linear model is suitable for a data set. Okay, what does that mean? Well, let's take this data set here. I've recorded how hot it is every day and how many soft drinks I'm selling. Now, we would expect the hotter it gets, the more soft drinks I'm going to sell. By the way, this temperature is in Celsius, not Fahrenheit. So first thing I could do with this data set is graph it, and it looks like this. Now you can see I've added a trend line here. Yeah? So the blue is my original data set. It looks linear. It looks like it's generally trending up in a straight line. But guys, in maths, we never are about, oh, it looks like it's that way. I reckon it's probably like that. No, we need to be precise. So a residual is going to make us say, beyond a shadow of a doubt, that a linear model is appropriate for this data set. So one thing I can do, if I've chucked in a trend line like this, I can use technology. So I could use Excel or I could use my calculator to do a regression. So I've come up with y equals 4.32x plus 2.43. So x is the temperature. So that's how hot it is. That is my exponential variable. Y is sales. So it's fair to assume that my sales are going to be affected by how hot it is, not the other way around. Okay then. As you can see, the trend line didn't perfectly fit the data set. It was close, particularly with this data point here, but for other ones it was a bit further off. So what we need to do is we would create a table like this. So the predicted value based on regression. So what I've done is I've taken my formula here and I've substituted every single temperature point into that. So my first temperature point was 19 degrees, as you can see up here, first temperature point, 19 degrees. And I've substituted into my formula that I found here, 4.32 times 19, my first temperature point, plus 2.43, as my equation says here. And that gives me a predicted value of 84.51. What does that mean? Well, looking at my graph here, when it was 19 degrees, I actually sold 65 soft drinks, but according to my graph, when it was 19 degrees, I actually sold about 84, according to my regression here. See? So 19 degrees, I sold about 84, but in reality, I sold 65. So there's a clear discrepancy there. Anyway, so I would do that again for the next data point. So when it was 24 degrees, I substituted that in, 4.32 times 24 plus 2.43 equals 106.11. Now look, I could do that again and again and again. I've used technology. So I have 3 columns here. This is my original data here. This is what actually happened. Over here is what I am predicting will happen using my regression. Now it might seem strange to say predicted, because, well, we know what really happened, but I'm comparing what actually happened to what my model says should have happened. Anyway, that's all very well and good, but ultimately I've just turned this into a bunch of numbers. Residual, actually here we go, I've graphed both of them next to each other. So, blue is my original data, orange is my predicted value. As you can see, the orange ones are in a straight line, just like my regression. Okay, cool. I could add a trend line here, and we end up with something that looks like that. As you can see, nice straight line. But as I pointed out before, there's some discrepancies here. So there's a bunch of blue dots that don't fall on the orange line. Recall when you were younger, when you were asked to do a line of best fit, you would just draw it manually with half the dots above, half the dots below. And that's kind of what's happened here. Anyway, so to do a residual plot, we need to find residuals. Yes, I know, it's taken a while, but we're getting there. So to find a residual value, it is the actual y value minus the predicted y value. In other words, what actually happened, my actual sales of soft drinks, minus my predicted sales at 19 degrees. So for me, my first data point, it was 19 degrees Celsius and we sold 65 cans of soft drink. So the first data point is 1965. The residual value is my actual y, which in this instance is 65, minus my predicted y, which in this instance is 84.51. 64.51. So I've got 84.51 down here and 65 here. I actually sold 65, but my model is saying I should have sold 84. See how there is discrepancy. I actually sold 65. My model is saying I should have sold 84. So if I subtract those two figures, I end up with a residual of negative 19. Actually minus predicted. So if I go 65 minus 84, I'm going to end up with a negative, which is negative 19. So I do that for every single data point. Now, clearly that's very tedious. You might want to do that using Excel, but if it's a smaller data set, there's nothing saying you can't do it manually. Then I've graphed it. So what have I graphed? I've graphed my X data and my residual. So I have graphed these two columns, the ones in yellow. And it looks like this. See how the dots are random? It looks like just an explosion of dots, but that's actually good that it's randomly distributed. Remember, my first one was negative. My next one, actual minus predicted, is going to be positive. Negative, positive, 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 a little bit negative, but still negative. And hey, that's what's happened here. Negative, positive, 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 little bit negative. So I know I say it's a random distribution of dots, but it does actually match what happened above. Now, why is it good that it's random? Well, a random distribution of dots tells me a linear model is appropriate. If it's not random, so if I end up with a parabola or an inverted parabola or even a straight line going like this, then a linear model is not appropriate. Now, that's all you really need to know about residuals, but if you're curious why a linear model is not appropriate, I'm going to talk about that in part 2. Thanks for listening, guys. Please remember to like, subscribe, and click that bell icon.